Hey everybody, Mr. Elliott here. How you doing today? I have what I think is going to be the shortest video lesson of the year. So let's do it. So in class, I mentioned the log change of base formula. At the beginning of class tomorrow, I'll show where the change of base formula comes from, but now you just need to assume that it's some kind of math magic that came out of nowhere. But it did come somewhere, and I'll show that to you tomorrow. That formula was log base b of x was equal to log base w of x divided by log base w of b. And the question people always ask me is, what is w? Where did it come from? Well, w can be any number you want. It could be log base 1, log base 2, log base 3. I think it could even be like log base pi. Weird. But most people choose 10 or e because once you do log base 10, most of your calculators will only do logs in base 10, especially the calculator I recommend for this class, this particular one. Our calculator also does e. Today's probably the only day this year I'll even mention the number e. But number e, that's an interesting one because log base e of x is actually called the natural log of x. And that's not something you're going to use until like late pre-calculus or maybe even calculus. You'll learn all about your good buddy e. E. Anyway, let's use change of base formula here to solve these problems. Now, here I have log base 4 of 64. Now, if we use the change of base the way that we intended, it's log, I'm going to write the 10 just because it gets, sometimes, I like to see the 10, but you don't have to have the 10. So I have log base 10 of 64 divided by log base 10 of 4. And at this point, I can just pick up my calculator and type it up and see what happens. Parentheses for the numerator, log of 64, close that, divided by parentheses, log of 4, close parentheses, and it gave me an answer of 3. That's a really simple answer. Oh yeah, 4 to the what equals 64, 4 to the 3 equals 64. So this is actually a problem that's more likely to show up on the non-calculator half, but I just wanted to show you that even though it's a non-calculator problem, you can use your calculator to still get that answer. And while I'm thinking about it, I'm curious if you really had to put that denominator log in parentheses, the numerator and denominator log in parentheses. So I'm just going to go log 64 divided by log 3 or log 4 without putting in that set of parentheses. Oh, and it still gave me an answer of 3. So I guess that extra set of parentheses was not necessary. Okay, number 2. You should always see first if you actually need your calculator or not. 4 to the what equals 20. I don't know that one off the top of my head. I know that 4 squared is 16 and 4 cubed is 64. So the answer is going to be between 2 and 3, probably closer to the 2 end. Maybe 2.1, 2.2. Let's find out. If I use change of base, it would be log of 20 divided by log of 4. This time I'm not going to write the 10 because the 10 is assumed if you do not write it. And then if I type this into my calculator, and I'm looking for an answer somewhere between 2 and 3, closer to 2. So log 20, close parentheses, divided by log 4, and 2.16. We go to 3 decimal spots in this class, so 2.16, and that should be a 1 because that 0 rounds up to a 1. So 2.161. Example 3, log 200, log base 5 of 200. 5 to the what? 5 to the 3 is 125. 5 to the 4 is 625. So this is definitely not a hand problem, doing it by hand problem. So I have log 200 divided by log 5. I said somewhere between 3 and 4, but 200 is a little bit closer to that 125 than it is to the 625. So I'm going to guess 3.2. 3.2. Log 200 clear divided by log 5. 3.292. Well, if you round it, it should be 3.3. So Elliot was pretty close in his head, but at the end of the day, if we're going to go with thousandth of accuracy, 3.292. Last one, number 4, log base 6 of 36. I can do this one in my head. 6 squared is 36. That means that the answer is 2. No work necessary. So always check beforehand. Maybe you don't even need a calculator to solve it, but if you do need the calculator, you can use change of base. I did it, everybody. It's 5 minutes, 30 seconds. This lesson got done under 6 minutes. Booyah! Have a great day, a great weekend. Don't forget to watch your Michigan football game on Saturday. Bye-bye.